Grade 8s, we're going to do a little review of 5.1 to 5.3 in preparation for the test. We're going to look at deduction and inference today. When we make deductions or when we deduce, we make conclusion statements or observations about the evidence that's right in front of us. And we can do this by looking at the largest data. We can look at the smallest data. We can also look at the rate of change. We calculate this by dividing the difference divided by the original. We can also look at all three measures of central tendency, the mean, the median, and the mode. And we can also look at trends. So sometimes on graphs, you'll see this, on a scatter plot graph, you might have these little points that have that lead to a straight line going upwards, so an upwards trend or a downward trend. We can also find those anomalies. So if you had a set of data that we know is right here, and it clearly does not fit with the trend, we'll make an observation of that. That's something that doesn't seem to fit with the rest of the data. And after this, we can also look at multiple values. So you can pick a set of data that is from the earlier part of the table and look at it at the later part of the table, and what is the relationship between the two of them: larger, smaller, rate of change. Once we've done all those observations, that's kind of basic. We want to make an inference, and when we infer, we basically answer one question, and that one question is why. So why is that value so small? What was happening in that year? What was happening to that group? We can also look at why is that value so large? What was the change? What happened in that year or for that group of people? Where does the trend come from? With the introduction of a new piece of technology that might increase sales. Why is it such a great rate of change? Maybe something extraordinarily happened that year, like a cataclysmic event, of nature, like a volcano or a tsunami, which might have an enormous impact on a country. You also can look at the three measures of central tendency, and sometimes they vary quite a bit, and that can also be really interesting. Why would they vary so much? Why would the mean be so much larger than the median or the mode? And finally, what is that anomaly? We talked just earlier about that anomaly, that one piece of data that just doesn't fit. Why doesn't that data fit? What does that data represent? We're going to take a look at some deductions and observations based on this. This is Canada's Olympic medal count for the Winter Games between 1924 in Chamonix and Vancouver in 2010. First observation, we can see that the greatest medal count for Canadian athletes in the Winter Games occurred in 2010 Vancouver with 26 medals. That's a really complete deduction that I've made. Another deduction we can make: on 4 separate occasions, we had the smallest medal count. And you can notice a second deduction, you could say that these happened on primarily it happened on the earlier Winter Games, the first 3 of the 4 Winter Games plus midway through in 1972. We can also make a deduction based on the rate of change. So when I was looking at the data, I noticed that between 1928 and 1932, there's this huge jump from 1 medal to 7 medals, which is pretty incredible. So let's do the rate of change. The numerator is the difference, and in this case, it's 7 minus 1, which gives us 6, divided by the original. The original was 1. In 1928, which is the earlier date, they only had 1 medal. In 1932, 7 medals. So the earlier is the original in this case. So 7 minus 1 divided by 1, or 6 divided by 1. We then multiply it by 100 to get it into a percentage. So this rate of change from 1928 to 1932 is a 600% increase. And I'm not sure that there's anywhere else in here that is anything close to that. We look at this numbers like 13 to 15 or 7 to 13, it's almost 100% increase, but nothing like this. So something really special happened between 1928 and 1932. We can also make a deduction about a trend. 4, 5, 7, 13, 15, 17, 24, 26. This is pretty clear that this is an upward trend. So every year beginning in 1984, the Canadian Olympic team increased their medal count. Very simple deduction based on this trend that we've noticed right here. So now we're going to do one inference. We're going to look at this set of statistics, this trend, 4, 5, 7, 13, 15, 17, 24, 26. And we ask that all-important question, why? Why would the medal count rise so consistently? What is it that has happened in this time? Well, one inference we can make is that maybe the Canadian government was pouring more money into the Olympic program. So that's, sometimes money equals success in athletics. Secondly, during this time period, we hosted the Olympic Games twice, once in '88 in Calgary and Vancouver in 2010. How does that have an impact? Well, it's national pride. If you look at all these others, we don't have one occasion where we were hosting it in Canada. And so you ask yourself, do we want to win a bunch of medals when we're hosting it? And we don't look like fools, of course. So more money goes into the program at that time. And one in particular, actually, and this is one of the parts of inference, which is so important, is prior knowledge. And if you were watching the Vancouver Olympics in 2010, there was a program called Own the Podium. And what that meant was that the Canadians wanted to win as many possible medals on their own soil. They wanted to own the podium, and it was a very aggressive campaign. And it really caught up the spirit of the Olympics for the Canadian team, and the results obviously show 14 golds, the highest gold medal count we've ever received, with a total of 26 medals. There you go.